assignment to do.
Okay.
Okay, section 2.4, complex numbers. You guys know this as the imaginary number. And the imaginary number comes from situations when you have to take the square root of a negative number. And in all honesty, I that's a hard concept to wrap your head around, like square root of a negative number. You guys have been told now for 5 years that when you get the square root of a negative number, you can't do it, and you just say there's no solution and you move on. But now we're saying there's a solution. And all it means is that when you end up taking the square root of a negative number, it just means that whatever situation you are talking about, you have a graph that doesn't touch the x-axis. Whether or not it ends up being a parabola or it ends up being a power of 4, which has a graph that looks like that, it just means it doesn't cross the x-axis. When would you ever use the square root of a negative number? I don't have a lot of examples for you, but I do know that in electricity, the I comes up oftentimes. So if that's a field that you want to study someday, that would be an application of when you would use the square root of a negative number. But in terms of this class, it just means you are talking about a situation when the graph doesn't touch the x-axis. So I have a situation here, x squared plus 1 equals 0. Subtract 1 from each side, you get this x squared equals negative 1. Take the square root, get the square root of negative 1. Up until now, you would get a situation like that. You would say, oh, it doesn't cross the x-axis, no solution, and you'd move on. But mathematicians a long time ago said, okay, you know what? The square root of negative 1 is undefined, so we're going to call it an imaginary unit. And this right here, square root of a negative 1 is what you need. Whenever you have the square root of a negative number, you're going to want to make it so that it has the square root of a negative 1 in it, because there is a definition for the square root of negative 1. The square root of negative 1 is equal to I. Really, really important. So the square root of negative 1 is equal to I, so I squared is equal to negative 1. So in other words, if I were to square I squared, that is like taking the square root of negative 1 squared. And whenever you square the square root of something, you always end up with whatever's underneath the radical sign, so in this case you'd end up with a negative 1. This is really important too. You need to know this. You just need to know in your head that whenever you have an I squared, it means negative 1. So put a big old box around these two situations. If you can commit these two things to memory, I think you'll be in good shape. All right. Whenever you have an imaginary number that sits next to or is added to or subtracted from a real number, and when I say real number, I just mean a number that doesn't have an I in it, then you have what's called a complex number. So complex numbers are real numbers plus imaginary numbers. They oftentimes look like this, a plus bi. The a part doesn't have an I with it, so that would be considered the real part of the complex number. And then this bi part, because it has the I with it, that's the imaginary part. You add them together, you get together, they make a complex number. So here we have, let me start from the top here. The square root of negative 25. Well, look what I did to it. I said, okay, the square root of negative 25 really is the same thing as the square root of 25 times the square root of negative 1. Why did I do that? Why did I make it 25 times negative 1? Go ahead, Marcus.
Show us where the I come from.
Yeah, exactly. This thing right here, the square root of negative 1, we know what that means. What does the square root of negative 1 mean? It means I. Put a box in it just a few minutes ago. So, what is the square root of 25? It's 5. So then we still have the square root of negative 1. We still have the minus 7, so there's a minus 7 written here. Minus 7, minus 7. The definition of the square root of negative 1 is I. So we have 5i minus 7. This part right here, the minus 7, that's the real part. This 5i, that's the imaginary part. So together, when you have an imaginary number combined with a real number together, they make a complex number. Okay. When you are adding and subtracting complex numbers, don't make this harder than it is. I kind of like to think of the I like to treat it like it's an X. Treat it like it's an X. It doesn't mean the same thing, but treat it like it's an X. Combine like terms like you would normally. If you have a positive 6, which is a real number, and a negative 7, which is a real number, what do they make when you add them together? They make negative 1. So you have a negative 1, and then you have a 2i and a 4i. Those can be combined together because they are both imaginary. And so when I said I like to treat them like x's, it's kind of like having a 2x and a 4x. You add them together to get 6x, but it's not an x, it's 9. So we have negative 1 plus 6i. Negative 1 is the real part, 6i is the imaginary part. Together they make a, what's it called when you make a complex number? Yeah. Subtracting them, same thing. Use your rules about subtracting polynomials. What do you do to the minus sign? What did I show you guys to do with the minus sign? Change it to a plus, make the 6 negative, make the negative 3i a positive 3i. So you have a 4 and you have a negative 6. You add them together, you get negative 2, and then you combine your 5i and your 3i, giving you 8i. Hopefully you're filling in your notes. If you already had these printed, you should be filling them in as we go. Multiplying complex numbers. All right, examples. The square root of negative 9 times the square root of negative 4. So the square root of negative 9, some of you already know what that means. But I am going, it's actually 3, it's 3 and an I. But I'm gonna write out the steps because these are your notes. And I want you to be able to refer back to them. So the square root of negative 9 really means the square root of 9 times the square root of negative 1. And we're going to multiply that by the square root of negative 4 really means the square root of 4 times the square root of negative 1. Okay, the square root of 9 is what? 3. The square root of negative 1 is I. What is the square root of 4? 2. What is the square root of negative 1? It is I. We're not done yet though. What's 3 times 2? What's I times I? I squared. What is I squared? It's negative 1. So really what we have here is 6 times negative 1. What's 6 times negative 1?
Negative 6.
All that, and we end up with negative 6. So the i's have disappeared. So knowing that, let's try this. 3 plus 2i times 4 minus 3i. What are we going to use? What can we use? If those were x's, what would you do? Multiplying though. There's no plus or minus, so we would, maybe I heard it. We'd FOIL them. Yeah. So we're going to do the same thing. 3 times 4? What's 3 times 4? 12. And then we're going to do 3 times negative 3i, which is negative 9i. We have 2i times 4. 8i. And then we have 2i times negative 3i. Well, 2 times 3, 2 times negative 3 is negative 6, and then we have an I times an I, which is I squared. So let's clean this up. This is equal to, we have a 12 that cannot be combined with anything else, so we leave it at 12. We have a negative 9i and a positive 8i. What does that give us? Negative 1i. I'm just going to write negative I. And then here we have a minus 6, but I squared really means negative 1. So I actually have a minus 6 times negative 1. Let's clean it up again. We have a 12. We have a minus I. Negative 6 times negative 1 is positive 6. One more step. Oh, 18. We have an 18 minus I. Anything I can clear up? Yes.
Why do you like Michael Patty?
I don't know.
Because she is.
I am fancy.
That's
right?
fancy.
Are you right or wrong?
It
is. That's the proper way to do it.
Alright, 4I times negative 6 minus 2I. So we're distributing 4I into negative 6, 4I into negative 2I. What is 4I times negative 6?
Negative 24I.
Negative 24I. Very nice. 4I times negative 2I. It's negative, what's 4 times 2? 8, and then we have an I times an I, that gives us an I squared. All I'm doing is distributing. No FOIL in this time, we're just distributing. Alright, so we have a negative 24I minus 8I squared. That really means negative 24I minus 8 times what? What's I squared?
Negative 1.
Negative 1. Which is equal to negative 24I, what?
Plus
Plus 8.
Is it okay if we put 8 minus?
Yes, absolutely. Yep, it is certainly okay to write 8 minus 24I instead. Yep. All right, 6 plus 5I squared. 6 plus 5I squared means 6 plus 5I times 6 plus 5I, which is equal to, well, are you guys okay with that? 6 plus 5I squared means 6 plus 5I times 6 plus 5I. Should be okay, yeah. All right, we're gonna FOIL. 6 times 6 is 36. 6 times 5I is 30I. 5I times 6 is 30I, and then 5I times 5I is a positive 25I squared. Equals 36. What's 30I and 30I? 60I. And then we have 25 times
Negative 1.
very good. Equals 36 plus 60I. Those two give me negative 25. 25 times negative 1 is negative 25. Which is equal to 36 and a minus 25 can be combined to give me 11 plus 60I. Yes?
So you know how when you see the I squared, you know it equals negative 1?
Yep.
Earlier we said that like never mind. I just forgot.
Alright, this right here, 5 plus 2I times 5 minus 2I. What is different about this, 5 plus 2I times 5 minus 2I, than right above? Yes.
There's a minus.
There's a minus sign. Get used to seeing that. Get used to seeing that because that is a really, really helpful technique to be comfortable with because you're going to need this year, and if you're taking calc next year, you're going to need it over and over and over again. These two binomials are called conjugates of each other. They're called complex conjugates. And you will see later why they're helpful. But for right now, you just need to understand that when you have a situation like this, when everything is the same about them except for the plus and minus, they're called conjugates. Okay? All right, here we go. We're going to multiply these. 5 times 5 is 25. 5 times negative 2I is negative 10I. 2I times 5 is 10I. then 2i times negative 2i is negative 4i squared. What happened when I did this? What do we just create?
The thing where you cancel out the.
Those cancel out. And that will always happen if those binomials that you are multiplying are exactly the same, except for the plus minus part. Okay?
And then those,
And we gotta just, clean it up. And what's gonna happen?
it's gonna equal 29.
Oh yeah, all our i's are gonna disappear. So we're gonna have 25 minus 4 times negative 1, which is equal to, now negative 4 times 1 is a positive 4, added to 25 is going to get us 29. So the i's disappear when you multiply by the conjugate. Complex conjugates. Alright, we're almost done, you guys. Complex conjugates are kind of defined here. A plus bi and a minus bi, exactly the same except for the plus minus. And I put a little note here, and you're going to want to do this too, that whenever you want something to look different, and I'll explain what I mean by that later, you're going to want to multiply by the conjugate. So multiply 7 minus 2i by its complex conjugate. 7 plus 2i. 7 minus 2i and 7 plus 2i are called complex conjugates. Did I say it wrong the first time too?
Yes.
Okay, sorry. 7 minus 2i and 7 plus 2i are complex conjugates. We're supposed to multiply them. What do we know based on what we saw above? What's going to happen?
All the i's are gonna
It's
cancel
going to be a
out.
number. The i's are going to go bye-bye. Yes, so let's do it. 7 times 7 is 49. 7 times a positive 2i is 14i. Negative 2i times 7 is negative 14i. And then negative 2i times positive 2i is a negative 4i squared. 14 i's cancel out, leaving us with 49 plus 4. Because this, and I kind of skipped a step here, that's negative 1. So negative 4 times negative 1 is a positive 4. We have 49 plus 4, which is 53. So when you multiply conjugates, again, notice you got rid of the I. So brings me to my next point here. 6 minus 4i divided by 2 plus 3i. It is not proper to leave something in fraction form with i's on the bottom. So you want to get rid of them. How can we get rid of there being an I on the bottom? Remember how we had this situation, 7 minus 2i times 7 plus 2i? When we multiplied by its conjugate, we got rid of the i's.
So do we multiply by
So.
the conjugate of?
Yeah, so we are going to multiply by the conjugate on the bottom, but this is the deal. We can't change the value of this expression because we're just multiplying the bottom by the conjugate. We've changed the value. You can't just, that's an illegal move in math. You need to instead do this. 6 minus 4i divided by 2 plus 3i. I am going to, we just said we could get rid of the I on the bottom if we multiplied by the conjugate on the bottom. So I'm going to do that, but this is what I'm also going to do. I am going to multiply the top by the same thing. And the reason I'm going to multiply the top by the same thing is because when I multiply by this thing right here, 2 minus 3i over 2 minus 3i, I'm really multiplying by what?
1.
2 minus.
Yeah, somebody said it. Multiply by 1. So, like, if I multiply something by 4 over 4, what is 4 over 4?
1.
It's 1. So if I multiply by 1, I'm not changing the value of it. Do you understand what I'm saying? Like if you have 25 and you multiply it by 1, it's still 25. So as long as I multiply both the top and the bottom by exactly the same thing, that's a legal move, because you're just multiplying by 1. But we purposely picked it to look like this so that we could get rid of the I on the bottom. So let's do that. 2 foils here, but one of the foils, the one on the bottom, you guys should be getting pretty good at. Because you know what's going to happen to the middle terms. What's going to happen to the middle terms?
Cancel out.
They're going to cancel out, just like here. 14i and negative 14i cancel out. So 2 times 2 is 4. 2 times negative 3i is negative 6i. I'm not even going to write it down. And then a 3i times 2 is 6i. I'm not going to write it down because I know those are going to cancel out. But then you need to do 3i times negative 3i. That's negative 9i squared. Divided by the top. Do I have to do all the steps for FOIL? Are the tops conjugates of each other?
No.
They are not. So you must do all the steps. And the bottom, you know those middle terms are going to cancel out, so you can, you don't have to do all the steps. 6 times 12, 2, is 12. I gave you the answer. 6 times 2 is 12. 6 times negative 3i is negative 18i. Negative 4i times 2 is negative 8i. And then we have a negative 4i times negative 3i giving me a positive 12i squared. Now we got to clean this up. So we have a 12 on the top. Negative 18i minus 18i is negative 26i, right? Positive 12i squared. What is 12i squared? Negative 12. Because I squared is negative 1. 12 times negative 1 is negative 12. Divided by 4 plus 9. Very good. Because I squared is negative 1. Negative 9 times negative 1 is 9. So we really have 4 plus 9, which is 13. One more step. Well, maybe more than one step. What happens to our 12s on the top? Okay, now, is that always going to happen? No, that's a coincidence that it happens here, okay? So all we have left is negative 26i divided by 13.
Ooh.
I'm going to do this. We are not done yet. Because what is negative 26 divided by 13?
2 over 1.
Negative 2, not over. Oh, negative, yes. Negative 2 over 1, yes. We have an I next to it. Don't forget the I. So we end up with negative 2i.